In this video, I will be explaining how to derive the value at which the probability in Poisson distribution is maximum. In other words, what is the most probable value in Poisson distribution? Now, what is the formula for Poisson distribution? It is P of x equals e to the power minus lambda, lambda to the power x divided by factorial of x. Here lambda is Poisson parameter. This is equal to population mean. This is also equal to population variance. This formula gives the probability that there are x occurrences of the event under consideration in a given unit. Now we have to find what is the value of x at which p of x is maximum. X can take only discrete values. If it could take continuous values, we could have differentiated p of x to find its maximum value. However, x can take only discrete values. It can take non-negative integer values. So what do? We derive a recursive definition for p of x. Note that lambda to the power x can be written as lambda to the power x minus 1 into lambda. Factorial of x minus 1 can be written, factorial of x can be written as factorial of x minus 1 into x. So note this part, e to the power minus lambda, lambda to the power x minus 1 divided by factorial of x minus 1. What is this? As you can see, this is equal to p of x minus 1. So we get the recursive definition, p of x equals p of x minus 1 into lambda divided by x. Now this is the recursive definition we will use to find the maximum value of p of x. We consider three cases. One, x is less than lambda. P of x equals p of x minus 1 into lambda divided by x. Now if x is less than lambda, then lambda divided by x is greater than 1, which means p of x is greater than p of x minus 1. So what it really means is that as x is increasing, p of x is increasing. Now x is less than lambda. When x is less than lambda, then increase in x means that x is going closer to lambda. So we are finding that x moves closer to lambda, then p of x increases. Another case, x is greater than lambda. When x is greater than lambda, then lambda divided by x will be less than 1. So in that case, p of x is less than p of x minus 1. Or we can also say that p of x minus 1 is greater than p of x. Now, x is greater than lambda. So x minus 1 is closer to lambda. Right? So what it really means is that in this, as x is moving closer to lambda, then p of x is increasing. So in both cases, we found that when x moves closer to lambda, then x moves closer to lambda, then p of x is increasing. Okay. So what we found that p of x increases as x moves closer to lambda. So what it really means is that p of x is maximum when x is close to or near x is equal to lambda. Now p of x, as I found, why close to lambda? Why not always equal to lambda? That is because x can take only non-negative integer values. Okay, but lambda can take any real value. So we will consider two cases. One case when lambda itself is an integer. Now when lambda is an integer, then x can become equal to lambda. So in that case, p of lambda is maximum. Okay. But now again see the recursive definition. P of x equals p of x minus 1 into lambda divided by x. Now when x is equal to lambda, then lambda divided by x is equal to 1. So in that case, p of x equals p of x minus 1. What it really means is that when lambda is an integer, then p of x is maximum at x is equal to lambda and also at x is equal to lambda minus 1. Both probabilities will be equal. What if lambda is not an integer? Now if lambda is not an integer, then we know that probability will be maximum at integer closest to lambda, because we found that when x moves closer to lambda, then probability is increasing, and we know that x can take only integer values. So this means that when lambda is not an integer, then probability will be maximum at x closest to lambda. Now what are the closest possible integers to lambda? They are floor of lambda and ceiling of lambda. Floor of lambda is the highest integer less than lambda. ceiling of lambda is the smallest integer greater than lambda. To give an example, if 5.3 is the value of lambda, then floor of lambda is 5 and the ceiling of lambda is 6. So we know that p of x will be maximum at one of these values. Now let us find which of these values will give the maximum probability. Again we use the recursive definition, p of x equals p of x minus 1 into lambda divided by x. Now if x is not an integer, then ceiling of x and ceiling of lambda and floor of lambda, they differ by 1. Again take the example, if lambda is 5.3, then ceiling is 6 and floor is 5, difference is 1. So what it really means is that if it substitute ceiling of lambda for x, then x minus 1 will become equal to floor of lambda. So we get probability at ceiling of lambda is equal to probability at floor of lambda into lambda divided by ceiling of lambda. But we know that ceiling of lambda is greater than lambda. So what it really means is that probability at ceiling of lambda is less than probability at floor of lambda. So out of these, which one is greater? Probability at floor of lambda is greater. Okay. And we know that at one of these, the probability has to be maximum. Probability at floor of lambda is greater. So this means that probability is maximum at floor of lambda. So what do we conclude? We found that if lambda is an integer, then the probability is maximum at lambda and at lambda minus 1. If lambda is not an integer, then the probability is maximum at floor of lambda, that is at the largest integer less than lambda. Example, if lambda is 6, then both x is equal to 5 and x is equal to 6 will have the same probability, and this probability will be the maximum. If lambda is equal to 5.7, okay, then probability will be maximum at 5. So hope the derivation is clear for you. Thank you.